Hello everybody, welcome to lesson 0A. This is in section 3.1 of your textbooks, if you want to look it up on yourself. So, the purpose of this video is there are essentially 3 big points I want you to be able to do by the end. I want you to be able to describe the difference between an equation and an expression. What do we mean when we say equation? What do we mean when we say expression? I want you to understand what's meant by solving an equation. And I want you to be able to use algebraic manipulation to solve a linear equation. Okay? So let's start at a run. 3x plus 4 is equal to 6x minus 12. This here is an equation. An equation is our way of saying that something is equal to something else. They have the same numeric value. So we're saying that this left-hand side is equal to this right-hand side. Okay? It's a statement about something that we say is true that we then use as a big clue to figure out what the value of x is in this case. Okay, so these parts of it, the left-hand side and the right-hand side, these are both called expressions. Expression. Okay? So an equation isn't just an expression. So for instance, sine of x or 3x minus 17, these aren't equations, they're expressions. Okay? An equation is us saying that this expression here has the same value as this expression here. The word equals is in the name. It's an equation if it has an equal sign in it. Okay. So, in other words, if it's an equation if you see the equal sign and there's 2 sides to it. Some stuff on the left-hand side, some stuff on the right-hand side. So this sign is an expression. An equation is a relationship between 2 expressions. Hope that makes sense. Okay, so what do we mean when we say solve an equation? What do we mean when we talk about the solution to an equation? Well, the idea here is that usually in equations, it's not just a relationship between 2 numbers. There's usually some variables involved here. And so by solution, we mean find the value of x that makes this left-hand side equal to the right-hand side. Let's try a simple example. 2x is equal to 6. So in this case, x is equal to 3 is the solution. What do we mean when we say 3 is the solution to this equation? We mean that if you replace this x with a 3, 2 times 3, all I've done is I've replaced this x with a 3, and then evaluate that. 2 times 3 is 6. If I replace this x with a 3, you end up with a number where these 2 numbers are equal. The expression on the left-hand side is equal to the expression on the right-hand side. Hooray! That's what we mean by solution. Okay? So a solution is us trying to find which values of x make the left-hand side equal to the right-hand side. Now before I go on, some equations have a single solution. So for instance, 2x is equal to 6. This one only had one solution. x is equal to 3 is the solution. And what this means is if you try any other value, so for instance, let me try x is equal to 4. X is equal to 4. Replace the x with a 4. 8. 8 is not equal to 6. So 4 isn't a solution. So sometimes our equations only have one solution. Sometimes there's more than one solution. Sometimes there's no solution. So for instance, look at this expression. Minus 7 is equal to 6. There's no x in this equation. There's no variable. So no value of x will cause this to be true. We'll set the left-hand side equal to the right-hand side. This statement's just not true. There's no solution. No way to make it true. Okay? So some equations have one solution. There are some equations that have 2 or 3 solutions. Some equations have no solutions. And some equations have an infinite number of solutions. So for example, 4 times x is equal to 4 times x. We can try a bunch of these. X is equal to 2. Let's plug it in. You get 4 times 2 is equal to 4 times 2. That's 8 is equal to 8. So 2 is a solution to this equation. What about this one? X is equal to 3. 4 times 3 is equal to 4 times 3. 12. No, 12 is equal to 12. Hey, that's true. So x equals 3 is a solution. Any number you plug into this equation is a solution to it. So it has an infinite number of solutions. Okay, so why am I bringing this up? There's often in this course we'll be consulting with an equation. We'll be asked to find the solution to an equation. Usually the equation we'll see will be like this one, where there's 1, sometimes 2, sometimes 3 different solutions to it. Very rarely will we ever see expressions like this or like this. But sometimes there's no solution, and sometimes there's an infinite number of solutions. And it's important to know when these happen. So that's just a side note. Let's get back to it. Algebraic manipulations. Okay. So let's consider a simple equation. Plus x is equal to 6 plus... Oh, no, hold on. Oh, the problems of doing live video. All right. I should just follow my notes. 2x is equal to 6. Start with this one. Here is a really fun idea. That idea here is that there is a solution here. Solution is x is equal to 3. So we can try it. 2 times 3 is equal to 6. 6, cool. Okay. This isn't just an expression, it's an equation. There's an expression on the left-hand side and an expression on the right-hand side, and we're saying that these two numbers, the one on the left-hand side and the one on the right-hand side, we're saying these two numbers are equal. Why is that interesting? Well, you can do things. If I add, for instance, 4 to this side, and I add 4 to this side, then I will get 2x plus 4, 6 plus 4. This number will be equal to this number. What do I mean by that? I mean that that since this number is equal to this number, and since I added the same amount to both sides, the resulting numbers must be equal. And this is really neat because what I end up with is an entirely new equation. It's different from the original one, right? This one has a 4 in it. This one's 10 instead of 6. You get a different equation, an equation involving different expressions. But the neat thing is these two values are going to be equal, and so the solution will need to be equal too. So let's plug 3 into this. 2 times 3 plus 4. So that's 6 plus 4 is equal to 10. So 10 is indeed equal to 10. Hooray! In other words, if I add the same amount to both sides, you end up with this, and this number is still going to be equal to that number for the same solution value. And this argument works for multiplication by anything other than 0. It works for division for any number other than 0. It works for addition, and it works for subtraction. In other words, all of the basic algebraic basic algebraic techniques, manipulations you can do, addition, subtraction, as long as you do it to both sides, the solution value is going to be the same. This number will still be equal to this number for x is equal to 3. And that means that we can use algebraic manipulations, addition on both sides, subtraction on both sides, and multiply both sides by the same number, etc., to solve, as a technique for solving a given linear equation. So let's try one here. 2x is equal to 6. I want to figure out what the value of x is. I'm going to divide both sides by the number 3. So it's 2 over 3 times x is equal to 6 over 3 is equal to 2. Okay? So this one has the solution x is equal to 3, and then 2 over 3 times 3 is equal to 2, and this is equal to 2 is equal to 2. X is equal to 3 is a solution of this one. Dividing by the same number did the same thing on both sides. Okay. So, now to the fun part. Like I said, we can use algebraic manipulations as long as we do the same thing to both sides to isolate finding the solution to a linear equation. All right, so 3x plus 4 is equal to 10. I want to figure out what value of x will solve this equation. How am I going to do it? I'm going to use addition by a constant number, subtraction by a constant number, multiplication by a constant number, or division by a constant number. These 4 operations, as long as I add the same number to both sides, I'll get the equation will have the same information into it. So I'm going to use these 4 operations to isolate x. That's the point. We're trying to isolate the value of x so that x is on one side and some number is on the other side. So how am I going to do it? Well, the idea here is that there's the x that I'm trying to isolate. It's multiplied by a number. There's a number over here, and this is another number added to it. So what I'm going to start by doing is I'm going to try to get rid of this constant expression here. It's been added to the x, so I'm going to use subtraction to cancel it out. 3x plus 4 minus 4 to cancel it out. And I have to subtract 4 from the other side as well. It's really important to remember to do the same operation on both sides. The result, 6. So I'll make a note here of what I've done. Subtract by 4. And now I have another equation. This expression is equal to this expression. I want to isolate the x. In this case, the x has been multiplied by 3. So I'm going to divide both sides. Adding and subtraction are a pair. Multiplication and division are a pair. If something's been added, you can use subtraction to get rid of it. If something has been multiplied, you can use division to get rid of it. So I'm going to divide by 3. I'm going to divide both sides by 3. Whoops. 6 over 3. And now I'm going to simplify. The 3's cancel out, and I get 6 over 3 is equal to 2. So x is equal to 2. And the nice thing about this is because I've done the same operation on both sides all the way down, this solution to this equation must be the same solution to this one. That's the argument. It always pays to check. So I'm going to check my proposed solution that x is equal to 2 by putting it back in this equation. 3 times 2 plus 4 is equal to 10. 6 plus 4 is equal to 10. 10 is equal to 10. Hooray! It worked! Okay. So the nice thing about this is that we can do it to more complicated expressions. Let's try another example. 4x plus 2 is equal to 5x plus 1. I want to isolate x on one side. I could isolate it on the left-hand side or the right-hand side. I usually like doing the left-hand side, but it's up to you which one you do. So I want to isolate this value of x. So, well, let's see. There's 2 in front of it, so I'm going to subtract 2 from both sides. Both sides. Minus 2. If I do it to both sides, the number on the left side of the equal sign and the number of the right-hand side will still be equal. Subtract 2. All right. And now I'm going to simplify this. 4x is equal to 5x minus 1. There's x's on both sides, x terms on both sides. So I'm going to subtract both sides by 5x to cancel out the 5x on this side. 4x minus 5x is equal to 5x minus 1 minus 5x. Subtract 5x from both sides. It's super important to do it both sides. If I do it, then this side becomes minus 1x, and this side is equal to minus 1. And now I'm going to divide both of these by minus 1, the coefficient in front of the x. The resulting equation tells me the solution. X must be equal to 1. So let's check. So 4 times 1 plus 2 is equal to 5 times 1 plus 1. So this is equal to 4 plus 2 is equal to 5 plus 1. 6 is equal to 6. Yes, it worked. Okay. So in class, in the worksheets, you can try more examples like this. Let's review what we've just talked about. There's something important here. The medicine wheel for this particular lesson looks like this. Plus, minus, division, multiplication. There's an interesting point here, and that's it's that basic algebraic operations are related in pairs. Anything that can be done, any operation that can be done, has a pair that can undo it. So if we have a term that's added to our value of x, we can always use subtraction to get rid of that term. Every time there's a term that's multiplied by x, we can use division to cancel it out. And so we can use the fact that any time there's an operation that's done, it can be undone to rearrange our equation so that we isolate x on one side and then we get a pure number on the other, and that tells us the solution. So we can use this idea as our guide to simplify the equation so that the expression on the left is just an x and the expression on the right is just a number. Remember to do it to both sides of the equation, and remember to check your answer. All right, that's it for this video. Time for you to watch the next one in the sequence.